The lesson topic for this video is the change of base formula. Okay, so based on the log work we talked about in previous lessons, let's look at these four examples and identify what the base is for each of the logs. Okay, remember the base is the small subscript number right there. So in this case, the base is 7 because it's right there. Okay, the base of the next one is 3. And how about the next two? Well, we don't have that subscript number underneath or below the log right there, which means in both of these cases the log is in base 10. So it's important to remember that if the log or the base is not written in there, it is a 10. Okay, so this is log base 7 of 49, log base 3 of 10, log base 10 of 100, and log base 10 of 60. Remember that a common log is a log with a base of 10, so these are both common logs. The 10 is not written. So again, log 3 means log base 10 of 3. So these are the ones that can be evaluated with the log button on our calculators. And if you have your calculator handy, you can look for that button and make sure you find it. Let me know if you need any help. And as we've done in previous lessons already with logs, there are some log situations that we can evaluate without a calculator. So let's think about this one right here for a second. Log base 7 of 49. If we rewrote that one as an exponent situation, we would have 7 raised to the x power equals 40, right? Oops. All right, so 7 raised to what power is 49? Well, we know that one because 7 raised to the second power, 7 squared, is 49. So x equals 2 in this situation. Even though it was a base of 7, we didn't need the log button on our calculator for that one. The next one, log base 3 of 10. If we rewrote that one, we'd have 3 raised to the x power equals 10. Okay, and we know 3 to the first power is 3, and 3 to the second power is 9, and then 3 to the third power is 27. So we know it's somewhere between 2 and 3, but we don't know what it is. So this one we can't evaluate right now, and also we can't use the log button to figure it out because it's not in base 10. This next one is in base 10, and we say 10 raised to the x power equals 100. Now this one we can do without a calculator again, because we know 10 to what power is 100? Well, 10 to the second power. 10 times 10 is 100. So this one is x equals 2 as well. And the next one is log of 60. Okay, and log of 60 is base 10, so 10 raised to the x power equals 60. Okay, and we can't evaluate that one again in our heads because x to the first power is, 10 to the first power is 10, and 10 to the second power is 100. So we know it's between 1 and 2. But we can use our calculator to figure this one out. So we can on our calculator, if you want to do that right now, hit log of 60 because that's in base 10, and we find out that x equals 1.778. Like we said, somewhere between 1 and 2. All right, so what this brings us to is, what about the rest of them? So the first one we were able to solve without a calculator, and the third one we were able to solve without a calculator, and the fourth one we were able to solve with our calculator because it was in base 10. What about this one? Well, we have to learn the change of base formula to help us solve that one. So this is the change of base formula right here. If you ever, on the previous screen, what was it? It was 3 to the x power equals 10, I believe it was. So 3 to the x power equals 10, which started off as log base 3 of 10. We would not be able to use our calculator to compute the log of 10 because the base is 3, not log base 10. So if we take that log with a base, which in this case is 3, and then the number here for x, which is 10, if we simply created a fraction with the common log of x in the numerator and the common log of a in the denominator, this would then evaluate this expression here, this log here. Let me show you an example right here, and that'll probably clear things up if that was a little confusing. So, since we have log base 7 of 40, that means we do not have a common log. So we can use the change of base formula, which will allow us to evaluate this log on our calculator. So log base 7 of 40 we are going to be able to rewrite this as the log, common log, so we don't need the 10 there, but the log base 10 of 40, so the number that is not the subscript, so this number here, over log base 10 of 7, which is the subscript number. Now since these are in log 10, we can just use our calculator to compute log of 40 over log of 7. Make sure that if these two numbers were divisible by each other that you do not simplify. You can't simplify this as a fractional situation because it's log of 40 over log of 7. So if this had been a 42, we can't just cancel this out and this and make that a 6. Okay, so we have to actually use our calculator to compute log of 40 divided by log of 7. All right, and when we do that, we find out that this will calculate to get 1.896 when rounded correctly. So log base 7 of 40 is 1.896. If I were you, I'd double check that that is what you get on your calculator as well. So how would we do the next one? Well, log base 3 of 8, we can't do a log with base 3 on our calculator, so we're going to change it to log base 10 of 8 over log base 10 of 3. And if I compute log base 8 or log of 8 over log of 3, we get 1.893. Wow, very similar answer to the previous one. Okay. Now notice the next one, log of 7. There is no base written in right here, which means it is base 10. So all we need to do on that one is hit log of 7, and we find out it's 0.845. You could have used the change of base formula for that, but there is really no use because we can just calculate it without that process. All right, go ahead and try the next 3 on your own and then check back to see how you did. I will provide the answers. Let me know in class if you didn't have the correct answers. Okay, the answers for those 3 are 1.860, negative 4.907, and we can definitely talk about that one in class if you need to. And this one, log of 680, that's already in the common log, and we can just type that into our calculator, and it's 2.833. All right, so the last thing we're doing here is actually solving these equations when the variable is in our exponent. So the first one, 5 to the x power equals 90. All right, so the first thing we want to do is we want to change this into a log. So we've got log, our base is 5 of 90 is equal to our exponent, which is x. Now, if we have log base 5 of 90, we know we need to use the change of base formula. So we're going to write log of something over log of something else. And I put something there. I want you to think for a second of which number goes where, and it's important. They can't just be swapped around. The numerator needs to be log of 90, and the denominator needs to be log of the base, which is 5. When we calculate log of 90 over log of 5, you will get 2.796 for x. Now you can double check that that worked out right by putting this value in for x right here. So 5 raised to this power should equal 90. Last one, we've got to change this into a log. Log base 65 of 9 equals x. Change of base formula, log of 9 over log of 65 equals x. If we compute log of 9 over log of 65, we're going to get 0.526. And again, if you plug that in right here, 65 raised to this power should give you 9. Double check it to make sure things look good.